Hello. This demonstration focuses on the safety security combined analysis and interference analysis which have been conducted on the use case 5. Let's start with the import of the system architecture from Chester Safety Architect. In Safety Architect, an import function allows to import chess model. After a little work on the layout, the system architecture is imported. The system architecture contains a processor which consists of 2 cores, and software components are allocated on the both cores. Next step, the safety analysis. Local safety analyses are performed on each components, hardware and software. A local safety analysis describes the failure condition of a component. It consists of internal failures, system or environment events and failure modes. Feared events are allocated on failure modes. Then, a fault tree is automatically generated for the feared event. Next step, the security analysis. Based on knowledge bases, threat sources are identified. Primary assets are identified. Supporting assets are identified. Based on knowledge bases, vulnerabilities are identified. The security feared events are also identified. Threat scenarios are identified. Attack trees can be designed. The security risk is assessed. Security measure is proposed to mitigate the risk. Considering the security measure, the risk assessment is updated. Next step, the combined safety security analysis. First, the security information are imported in Safety Architect. The security elements to be imported are selected, and an element of the system architecture, generally a port, is selected to receive the security elements. The import task must be repeated till all the required security elements have been imported. Safety Architect allows to overlay on a same diagram safety and security information. Then, some of the failure modes or vulnerabilities can conduct to safety and security events. For the safety or security feared events, trees are generated. They can contain safety and security elements. Next step, the interference analysis. An interference report can be generated for each safety security tree. From the nodes of the tree which are tagged according to their type, safety or security, metrics indicate the number of potential interferences. The report also presents the detailed list of potential interferences. When there are several iterations of the project, an interference evolution report can be generated. Interference reports and evolution reports can be used to detect and monitor the interferences, and they also give interesting materials to support discussions during a geoengineering meeting to find trade-offs. Throughout this process, the traceability of requirements is ensured by a RecIF plugin that is integrated into Safety Architect. The requirements are allocated to model elements. To conclude, 5 detected interferences concern the security components because if they fail, they can conduct a safety field events. These can be compensated by applying rigorous development method. One interference concerns the security components and the radiations. Indeed, the use of a cipher extends the length of the signal to be sent to Earth, yet the longer the signal is, higher is the probability occurrence to be perturbed by radiations. A co-engineering meeting is needed to discuss about the Rigendale algorithm and the possibility to implement checksum or hash function to mitigate the risk.